Hi, my name is Malespina, and this is some work that I've done with Christian Shun and my advisor, Chandrika Singh. It's titled To Whom Do Students Believe a Growth Mindset Applies, and these slides are available at the QR code on the top right corner of the screen. To start out, gender differences in introductory physics performance and persistence are well documented. This is due to many factors, including prior experience. So girls are less likely to have parents who believe they can succeed in math and science, and they're less likely to take advanced physics in high school. This can be due to classroom experiences, so treatment by peers and instructors and lack of female peers and role models. It can also be due to motivational beliefs, so people's beliefs about themselves and their relationships to physics. For example, self-efficacy, belonging, etc. But here we're going to focus on intelligence mindset. It's really important to note that all of these factors interact with and affect each other, as well as that none of these exist in a vacuum, but in a sea of messages about societal stereotypes and biases about who belongs and who can succeed in the sciences, especially physics. However, here I want to focus on the interactions of mindset, classroom experiences, and performance, because these are areas that instructors can actually influence. So, what is intelligence mindset? It was theorized by Carol Dweck and colleagues in the 1980s as a way to characterize how people view intelligence in learning. Those with a fixed mindset view intelligence as something that's innate and unchangeable, and are likely to view failures or setbacks as a sign that they're not smart enough or not good enough to succeed in a task. That they're more likely to disengage from tasks when they face challenges. On the other hand, people with growth mindsets believe that intelligence can be developed and strengthened like a muscle. They're more likely to view failures and mishaps as learning experiences and ways to become more intelligent, and they're more likely to persist in challenges when they're having some trouble. Growth mindsets have been linked to positive learning outcomes even after controlling for prior academic achievement. So growth mindsets aren't only linked to learning outcomes, but to greater participation in STEM fields for students in historically underrepresented groups. We theorize two mechanisms for this. First, growth mindsets might be useful as a way for students to combat stereotype threat. So having a growth mindset changes the narrative from I can't make mistakes because then I'll show my teacher that girls can't do math to everyone makes mistakes when they start out and I'm not an exception. Students in stereotype groups may also experience anxiety, which can limit working memory, which is a really important resource for learning. A growth mindset can also facilitate engagement and perseverance as strategies to reduce future anxiety. So, why mindset? We're interested in mindset for two reasons. First, it hasn't been studied much in physics. We have some evidence that physics-specific mindset is both different than and a better predictor of physics performance than general intelligence mindsets. Mindset might also be particularly important in physics because of a culture of what I'll call brilliance beliefs in physics. Brilliance beliefs aren't quite the same thing as mindset, but they do work in tandem. So, if a student thinks that raw talent is needed to succeed in a domain, and they believe that intelligence is unchangeable, then they're not going to see a path to success unless they already believe that they have that innate talent. This combination of beliefs may be pushing students away from physics. Another reason that we're interested in mindset is because mindset work in other fields has changed a lot in the past few years. Recent research has pointed to some subdivisions in intelligence mindset. So mindset was originally conceptualized as a continuum with fixed on one side and growth on the other, but some two-factor models that view growth and fixed mindsets as separate entities gained popularity in recent years, mostly due to superior model fits during validation. However, the divide that we're a lot more interested in here is the divide between beliefs about the self and beliefs about others. A 2015 study found that Australian high school students conceptualize intelligent mindsets very differently for themselves and for others. They also found that this mindset self-theory was a better predictor of academic performance than general intelligence mindsets. And finally, interventions are a popular tool to improve student mindset, but a recent meta-analysis found that both the methodology and the effectiveness of these interventions vary greatly, and the authors weren't able to fully explain why some interventions worked and others did not. So we want to find ways to make these interventions more effective. One way to do this might be changing the focus of them. For example, should we focus on mindsets generally or on individual students' ability to learn and grow? In this work, we seek to explore if there are any divisions in intelligence mindset, and if those divisions are useful, which leads us to our 3 research questions. First, do students have different mindset beliefs about themselves and others? Second, do students' mindset beliefs change over time? And third, do any mindset components predict course grade? A little bit about our student sample methodology. So our students are all from calculus-based Physics 1 courses. They were primarily engineering students with a smattering of other math, physics, chemistry students, and 35% of the enrolled students were women, which is pretty standard for this class in our university. Men have slightly higher SAT math scores, as you can see in the first line here, 718 versus 699, while women have slightly higher high school GPAs. However, men have higher Physics 1 grades. Women in this population tend to have better grades in their math courses a bit, so there's something specific to physics that needs explanation here. A little bit of information about our survey. We gave it at the start and the end of the semester during recitation, and we've put it through a few validation steps. We got all of the questions from our previous surveys, or we adapted questions. We did about 20 hours of interviews to make sure that students were interpreting questions the same way that we did, and we did confirmatory factor analysis to check the divisions. So that brings us to research question 1. Did students have different mindset beliefs about themselves and others? Yes, our confirmatory factor analysis shows that we have 4 distinct constructs, which were my growth, my ability, others' growth, and others' ability. This is consistent with some of the past work that I shared in the introduction. So we have some sample questions for each of these categories, though each category did have 3 to 4 questions in it. My growth, I can change my intelligence in physics quite a lot by working hard. My ability, I could never become really good at physics even if I were to work hard because I don't have the natural ability. Others' growth, people can change their intelligence quite a lot by working hard. And others' ability, to really excel in physics, people need to have a natural ability in physics. Again, we had more questions than that, but this is just so you get an idea of what we were asking them. This brings us to research questions 2. So do these students' mindset beliefs change over time? On the left here, I have a table that shows the statistics for each measure by gender at the beginning and at the beginning of the semester. On the pre-surveys, men and women had nearly identical scores for my growth, so about 3.6, others' growth, about 3.5 for both, and others' ability, about 3.5 for both. This means that at the beginning of the semester, most students have growth rather than fixed mindsets. The only pre-survey category with a significant gender difference is my ability. In this category, men had significantly higher scores than women. This means that women were more likely than men to believe that natural ability is important for themselves to succeed in physics at the start of the semester. However, by the end of the semester, there are gender differences in all 4 mindset categories. So one example is my growth. At the start of the semester, we see no significant gender difference. This is Cohen's D as an effect size measure. But by the end, the effect size, the difference between genders has a medium effect size. So there was a huge increase there. So these end of semester differences are more drastic in the my categories, so my growth, my ability, than in the other categories. This means that at the end of the semester, women are more likely than men to believe that natural ability is important for themselves and for others to succeed in physics, but especially themselves. We can also see that using growth as an example again, that both men and women's endorsement of a growth mindset went down over the course of the semester. So men went from about 3.6 to 3.5, women went from about 3.6 to 3.1. So another way that we can look at this data is to compare across time. So this first bar shows the effect size comparing women's my growth responses from the start to the end of the course. So it went down drastically. Women were much less likely to endorse a growth mindset for themselves at the end of the semester than at the beginning. We can see we can see this trend for men as well, though it's a lot less drastic. By the end of the semester, all students saw declines in my growth and my ability. As we can see here, negative effect sizes from the beginning to end of the semester. But women also saw decreases in others' growth and others' ability. So the declines in all 4 categories were larger for women than they were for men. This means that after their first university-level experience, both women and men became more likely to believe that natural ability is important for them to succeed in physics. Women also became more likely to believe that natural ability is important for anyone to do well in physics. These results suggest that the classroom environment led to students moving away from a growth mindset in the physics context. It also suggests that the classroom experience that influenced student mindsets affected men and women differently. Finally, we conducted a multiple regression analysis to find which mindset factors best predicted course grade. These first few models used the pre-survey results. So in Model 1, we only use gender, SAT math scores, and high school GPA as predictors. And this model shows that women have lower Physics 1 grades than men when controlling for prior academic preparation. If SAT math and high school grades don't account for gender differences, then we need to consider other factors. Model 2 includes my ability as a 4th predictor. Here, the pre-survey my ability is a significant predictor when controlling for gender and, for gender and prior academic preparation. Its addition also weakens the effect of the relationship between gender and grade, though gender does remain significant. Model 3 adds the remaining pre-survey mindset factors, so my growth, others' ability, and others' growth. This model is used kind of as a control to test if my ability was really the significant predictor here, and it is. None of these new factors are significant. Importantly, using pre-survey results, my ability is the mindset variable with the most predictive power, and it's also the variable with the largest gender difference, even when we're controlling for prior preparation. So these next results use the mean of the pre and the post-survey mindset scores. We're calling them average, and it's all longitudinally matched students. We did this because of the large changes in mindsets across the semester that we looked at when we were addressing research question 2. So Model 4 is identical to Model 1, but we're using a reduced sample set for the longitudinally matched students. Model 5 adds the average my ability as a predictor. Again, the gender estimate decreases, but a lot more drastically this time. The predictive power of average my ability is 2 or 3 times the size of pre-my ability. This means that the my ability factor accounts for a large portion of the gender difference in grade. Model 6 has all those remaining mindset factors, and none are significant predictors, so we can be confident in Model 5. So main takeaways. When we're performing these regressions, my growth, others' ability, and others' growth do not predict course grade, but both pre and average my ability do, even when controlling for gender and prior preparation. So physics self-mindset is a predictor of Physics 1 grade, and hopefully increasing my ability beliefs will increase students' performance as well as mitigate these gendered grade differences. Quick summary, so we found out that students do have measurable subcomponents of mindset, so my ability, my growth, others' ability, and others' growth. These mindset components change for the worse over the course of the semester. The my components change more than the others components, and the changes are more drastic for women than for men. And finally, my ability is the strongest predictor of Physics 1 grade. So what should we do? Intervening is really important in these introductory classes because students are building the skills that they need to succeed in college, and we're setting the groundwork for their next 4 or 6 years. Additionally, in this population, which is mostly engineers, or engineering students, women are more likely to leave the major due to concerns about low grades than men are. And that's true even if they have an A or a B average. Increasing students' liability beliefs may increase performance and thus retention, especially of women and other historically underrepresented groups in physics. So two suggestions that we have are to adopt interventions that target liability and to adopt a growth mindset for you as an instructor. So on our first suggestion, there are two primary approaches to mindset interventions. The first one, we focus on the student or people like them to show that they can personally grow and become more intelligent. And in the other, we use tools like neuroscience to show that brains can and do grow, which means that we can become more intelligent. The latter approach seems to be really well suited to students who hold a general fixed mindset, but it might not be the most useful approach to students who endorse a general growth mindset but a fixed self mindset. Finally, even if you don't have time in your class for interventions, the mindset of the instructor is so important. It can predict motivation and achievement of students in their class. Instructors with fixed mindsets tend to have really low expectations of their students if they don't think that they have this natural ability, and they won't encourage their students to persevere through challenges. On the other hand, instructors with growth mindsets will encourage students to embrace mistakes as a natural part of the learning process. They're going to congratulate persistence, and they'll praise students' effort rather than their intelligence. And something that really stood out for me from this Canning study that we cite is that the students in classes that were taught by professors with a growth mindset said that their instructors motivated them to do their best work, which I think is all we can ask for as instructors. And finally, this is a throwback slide from my introduction, but I think it's really important to remember that instructors aren't all-powerful. There are a ton of reasons that gender gaps persist in physics, and many of them have to do with students' experiences with their families, peers, previous instructors, and society at large. However, I really hope that this research is going to help us in our mission to thwart some of those other forces and transform as many physics classrooms as possible into equitable learning environments. Thank you so much. On this slide, I have my contact information, so my email, my website, and I have the QR code to these slides again. I would love to hear from you during the Q&A session or via email. Thanks so much.